Hello teacher, hello students, welcome to today's lesson on the intersection between geometrical solids. In our last lesson, we have seen the rules and steps used for the development of a right full cone, a truncated cone, and an oblique cone using a radial line development. Let's briefly revise the previous lesson as usual. Radial line development is employed for pyramids and single curved surfaces like cones, in which the apex is taken as center and the slant edge or generator as radius of its development. The two dimensions necessary to make the development of a cone surface are the slant height of the cone and the circumference of its base. For a right circular cone, the developed shape is a sector of a circle. The radius for this sector is the slant height of the cone, and the length around the perimeter of the sector is equal to the circumference of the base. The proportion of the height to the base diameter determines the size of the sector as shown on the screen. In our today's lesson, we will discuss the principles and classification of surface intersection, the steps to find a piercing point, the methods of locating points of intersection, and the steps used to locate the intersection of two regular prisms and their development. Let's proceed to our first topic. Students, do you know what an intersection is? Let's see. It's common to find intersecting planes and solids in the building of sheet metal structure like tanks, boilers, etc. To develop the patterns of such structures, it's important to find their intersection point or line before the development. The line of intersection of two surfaces is a line that is common to both. It may be considered the line that would contain the points in which the elements of one surface would pierce the other. In order to complete a view of a working drawing or a view necessary for developing the surface of intersecting geometric shapes, a drafter often must find the line of intersection between surfaces. On a sheet metal drawing, however, a sufficient number of points must be located to obtain an accurate line of intersection and an ultimately accurate development. The line of intersection of two surfaces is found by determining a number of points common to both surfaces and drawing a line or lines through these points in correct order. The resulting line of intersection may be straight, curved, or straight and curved depending upon the nature of the intersecting surfaces. The intersecting surfaces may be broadly classified under three categories. The intersection of plane surfaces, when two surfaces bounded by planes such as prism and pyramid intersect each other, the line of intersection is made up of straight line. the intersection of two curved surfaces. When two solids having curved surface like cylinder and cone intersect each other, the line of intersection is curve. The intersection of a plane surface and a curved surface. When two solids, one bounded by planes and the other having curved surface, such as prism and cylinder, intersect each other, the line of intersection is a curve. Well, students, how are you doing so far? I hope you are enjoying the lesson. Next, we'll discuss how to find piercing point. When a straight line intersects a plane, it pierces the plane at one point. This point is called a piercing point. The line can represent the lateral edge of a plane solid or the elements of a curved solid. The plane can represent the surface of a solid. On orthographic views, the piercing point of a line and a plane can be found either by cutting plane method or edge view method. When a line pierces a given oblique plane and an edge view is not given, a cutting plane may be used to establish a line of intersection that will contain the piercing point. To find the piercing point of line RS with plane ABC by cutting plane method, follow the following steps. Draw the horizontal view of the projecting plane through RHSH to establish DHEH as shown in the horizontal view in C. Locate DF, EF and draw the frontal view of the line of intersection. Complete the line view RF, SF to establish P1F at the point of intersection of RF, SF and DF, EF. Locate P1H on RH, SH by projecting upward from P1F as shown in D. Students, it's now time for an activity. Vertical and horizontal projections of plane ABC and line LM are given. Find the piercing point of the line and plane by cutting plane method. Welcome back. Did you do well on the exercise? I'm sure you did. The solution to the activity is given on your screen. Well, students, are you enjoying the lesson? Good. Let's discuss how to find the piercing point using an edge view method. This method is commonly used to find the line of intersection between intersecting solids with plane surfaces. As you see on the screen, the horizontal and vertical projection of planes RST and line XY are given on the figure. To find the piercing point of line XY with plane RST by edge view method, we should follow the following steps. Draw horizontal line from one of the vertices of the plane RHAH. Find the true length of line RH on the adjacent projection plane RVAV. Introduce an auxiliary projection plane 1 to find the edge view of plane RST and transfer distances from the horizontal projection plane to plane 1 using the concepts you have learned in chapter 3. The intersection point of line XV, YV with edge view of the plane RV, SV, TV will give the piercing point PV. Project the piercing point to the other views. Student, it's now time for an activity. Vertical and horizontal projections of a plane ABC and line LM are given. Find the piercing point of the line and plane using the edge view method. Welcome back. Did you complete the exercise? Excellent. The solution to the activity is given on your screen. Well, students, next we will see how to find the line of intersection of two prisms and develop the lateral surface. Prisms have only plane surfaces. Therefore, when one prism penetrates another prism, the intersection of surfaces results in straight lines only. Each intersection line starts and ends at points where edges of one prism meet a plane surface or edges of another prism. Also, the intersection line form a closed polygon. The following steps are used to find the line of intersection of two regular prisms. Draw the front and top views of both prisms. Label the corners of the end view of the horizontal prism in a clockwise direction, as shown on the screen by A, B, C, and D, along which the piercing points lie. Project points A, B, C, and D from end view to top view to intersect the edge view of the lateral surface of the vertical prism, along which the piercing points again lie. Project the same points A, B, C, and D from top view down to front view to intersect the projection lines of corresponding points from end view and establish the required piercing points that lie on the line of intersection. Connect the piercing points obtained at step 4 to complete the line of intersection of the two intersecting prisms. We should use the parallel line method of development to make the lateral surface of the prism. To develop the lateral surface of vertical prism, we should follow the following steps. Draw the stretch out base line passing through the base of the front view. Transfer the true length edges of the top view 1 to 2, 2 to 3, 3 to 4, and 4 to 1 along the stretch out line and label them. Draw perpendicular lines through labeled points of the stretch out line to establish the various lateral edge heights. Project the piercing points A, B, C, and D from front view onto the development to intersect corresponding lateral or vertical edges and establish the line of intersection. That means points A and C lie on lateral edges whose true distance can be measured from edge 3 of top view and transferred along the stretch out line each side. Connect the piercing points to complete the line of intersection on the development. Well, students, to develop the lateral surface of the horizontal prism, we can follow the steps used for developing a truncated prism. Now, let's do some activities to check how much you've understood the lesson. Two intersecting prisms are given on the screen. Find the line of intersection of these prisms. Also, develop their lateral surfaces. Don't forget to use the steps you have just learned. welcome back. Did you do the exercise? I'm sure you did. The solution to the activity is given on your screen. Well, students, I hope you have gained a lot of concepts from today's lesson. Before we come to the end of the program, let's summarize the main points. An intersection is a point or line where two geometric forms, such as lines or surfaces, meet or cross each other. The intersection of a line and a plane is referred to as the piercing point. Locations of piercing points can be found using either the edge view method or cutting plane method. Prisms are made up of planar surfaces, so all intersections will be straight lines. This means that you only need to find the ends of each intersection lines. Well, students, that brings us to the end of our lesson for today. In our next and final lesson and technical drawing for grade 12, we will learn about on the intersection of geometrical solids. Until then, thank you, teacher, and thank you, students. Goodbye.